Okay, students, hope you enjoyed the little musical introduction to get you in the mood for learning about matrices. All right, so what we're going to be looking at is reduced row echelon form of a matrix. And a lot of what you're going to be doing is you're going to be doing a lot with your calculator on here. I'm going to demonstrate how reduced row echelon form works by hand, but we're going to be using your calculator most of the time, which you'll appreciate. Okay, so to begin with, you need to know what is meant by reduced row echelon form. So we've talked about what matrices are, and reduced echelon form has a certain look to it. Okay, so first of all, each row consisting entirely of zeros is below any row having at least one non-zero element. All right, and I'll explain kind of how this goes with these examples here. And then the leftmost non-zero element in each row is 1, so that's kind of a key thing, right? All other elements in the column containing the leftmost one of a given row are zeros, right? And then the leftmost one in any row is to the right of the leftmost row above. And, you know, when you read this stuff, this is sort of easier to explain with examples than it is to just write down what this definition is. So I'm going to try to demonstrate that to you then, and just kind of on these examples, we'll kind of look at this. So these are all in reduced echelon form. Okay, so what you look for is you've got kind of your bar here. This is going to represent a solution to a system of equations. So you've got a 1, then a 0, then an answer. 0, 1, then an answer like that. That's the standard that you're going to see is like that. You kind of have a diagonal of 1s, a diagonal of 0s, the bar, and then what goes past this can be anything. So it doesn't really matter what's there, right? And then this next one's the same way. Just kind of focus in on this part right here. That's what you got to look at right there. That's what matters. So you have a diagonal of 1s. Everything else is a 0. These two examples right here are the standard of what you're going to see. So just kind of think of this one is like 2 equations and 2 unknowns. So just disregard that part. 1, 1, 0, 0. This is like 3 equations. Diagonal of 1s that way, everything else is zeros. Okay. This one's also the same as this one, except it's got a 0 there, and that's also okay. Right? You can end up having that then. You can have a 0 there, right? That's going to end up being one that has no solution. This one's also okay. Again, don't really pay any attention to this part. It's okay to have a 1, 0, 0, 0 like that. That's all right. And so you can end up having a row of zeros like that. Same thing here. This is just for 3 equations. You can have a row of zeros like that. All right. So all of those things right there are what we would call reduced row echelon form. The most common thing that you're going to see is this situation there. Okay, so you got kind of that situation there to look for. Then you also have this situation where you've got 1, 0, 0, 0, 1, 0, then nothing but zeros, right? Okay, so this is kind of the same thing. You can have 1, 0, 0, 0 like that. Same thing here. All right, so basically these are all the same as the first 2 examples, except that last row just has zeros. All right, so if you kind of think of it that way, that might help you a little bit then. All right. All right, so what I want you to do is just pause the video, look at the examples that I did there, and just determine whether you think these are in reduced row echelon form or not, and then we'll talk about why you get a yes or no. So go ahead and just do these yourself. Pause the video, come back and check. Okay, so this is what you should come up with. Now, I went through and identified out of the 4 things that you look for in reduced echelon form, I'm looking for being able to identify that. So this one right here is no, and the reason is this number 4 fails. This says the leftmost one in any row is to the right of the leftmost row above. Okay, well, these things are in backwards order. Okay, so this one really needs to say 1, 0, 2, 0, 1, 0. Okay, in order to meet that condition number 4, the leftmost one, which is this, is to the right of the leftmost row above. Okay, so that thing right there has got to be to the right of that. That's why that's not reduced row echelon form. Okay, this one is okay. You've got the leftmost one, then a 0. That's what matters. And it's okay to have a row of zeros. So if you read everything, this says each row consisting entirely of zeros is below any row having at least one non-zero element. So that satisfies that condition. Okay. And then this one's yes, that's standard. That's the one that you want to get most comfortable with. That's what you're looking for. That's just like this example there, right? This one right here, number 4, is no, and that's because the leftmost one needs to have a 0. That thing right there needs a 0. So if you look at condition number 3, it says all other elements in the column containing the leftmost one of a given row are zeros, right? So if that's the leftmost one, that's got to be a 0. Okay, then this one's okay. That one satisfies all the conditions. That's pretty similar to D. And then this one's no. Okay, that one, if this is your leftmost one, then that would have to be a 0. All right, so that's why. All right, so just kind of good to get an idea of what this is. Like I say, you'll be seeing all of these kind of situations here and mainly learning how to interpret them in a system of equations. Okay, next thing's pretty simple. What we're going to learn how to do is write a system into what we call an augmented matrix. And this is a system of equations. It's got 2 equations and 2 unknowns. So it's got 2 rows and it's got 2 columns. So what you do on your augmented matrix is something pretty simple. You just write down, kind of put a bar there. What these things are equal to goes here. So that's 8, -2. And then you just write this down. The coefficients, 2, -3. That's a 1. That's understood to have a 1 in front there, and then a 2. So that's what the augmented matrix is for that particular system of equations. Okay. And we're going to learn how to solve this on a calculator primarily. This one, again, has 3 equations and 3 unknowns. So when you might write the augmented matrix on this, then you'll have 3 rows. Write down past the bar, write down what each equation is equal to, and then the coefficient. So that first row would be 2, -5, 1. Second one is 1, 2. Now see, there's a missing x3, so that's a 0. Then you have a -3. You have a missing x2, so that's 0. Then you have a -1. So see, what you always want to have is kind of a column for x1, a column for x2, and a column for x3, and so forth. In this first example, you have those columns there, okay? All right, so that's the columns for the variables. This is what those are equal to. So there's really nothing to that. Go ahead and pause the video and write down what you think the augmented matrix will be for these 3 examples. Okay, so boys and girls, check your answers. This will be one of the simpler things you learn how to do all semester, okay? So this one, your first row is 1, 2, 1. Second row, -5, -2, -4. Be sure you have that bar. Next one, 6, -2, 0, 1, 0, 9. So you need to have that 0 there. And then the last one, 1, 1, 1, -1. Second row would be 1, -1, 0, 10. And then 2, 3, -1, 0. So that's all there is to that. All right, so moving on, we're going to look at how to do this in reverse. So the solution of a system of equations. So you want to know what how a reduced row echelon form gives you a solution in the matrix. So anytime you have 1, 0, 0, 1, that means this is the answer to the problem. So this really would be, you could think of this as x plus 0y equals m, and you could think of the next one as 0x plus y equals m. So this is just saying that x is equal to m and y is equal to n. So the solution would be the point Mn. Okay, that's the general solution to that system of equations. So when you have 1, 0, 0, 1, two equations and two unknowns, that gives really a point of intersection. Okay, so remember we've learned how to solve systems of equations by graphing, so that's what you get. Okay, that's the standard, that's the first one. Now, the next one would be if you have a row of zeros right here. Okay, so what this would mean, anytime you have a row of zeros, this would mean that you have the solution is there are infinite solutions. So we're going to learn on this to do what we call a parameterization when we write that solution to that system of equations. Okay. See, what this problem really means is this means you have x and y. You have really x plus my equals n. That second equation really says 0x plus 0y equals 0. And if you look at this and think about this, then basically x and y could be anything. Okay, that could actually be any number to satisfy that particular equation. 0 times anything is 0. 0 plus anything is 0. So no matter what x and y are, it would work. So that's all we're going to say in this so far is that we have infinite solutions. All right. Okay, and then the next one, if you have a 0, 0, and then a number that's not equal to 0, then we say this is no solution. Okay, now let me explain why. So what this means, again, this first equation means x plus some number m times y equals n, but this will help you understand this. If you look at this bottom row here, that says 0x plus 0y equals p. And that's impossible. So if you take any x and y, you would get 0 equals p. And we said in this particular problem that p is not equal to 0. What this would mean is that you have parallel lines because they don't intersect. Okay. And this number 2 would be the same line if you graph those two things. All right, so just kind of to summarize this, these are the three key situations you'll see. If you have 1, 0, 0, 1, that means the two lines intersect in that point Mn. This is what the system of equations is. You want to think about that. Okay, if you have a row of zeros, that means you have infinite solutions. And that just means if you graphed these two lines, it'd be the same line. Okay. In your original system of equations. And the reason is because of that last row means 0x plus 0y equals 0. Think about it. X and y could be any number that you could think of because it would work in that equation. And then number 3, when you have a 0, 0, then another number that's not 0, then it's no solution, meaning parallel lines. And that's because if you take 0 times a number plus 0 times another number, you'll never get a non-zero number. Okay, so that's what you want to think about in that then. All right, so we're going to move down here. I need to pause just for a second, get another cup of coffee. All right, so what I'm going to do is we're going to take these reduced row echelon form. We're going to write the system and we're going to write the solution. So we're kind of building up our skill level on this as we go. All right, so remember, I'm just going to use x and y. You could also use x1, x2 if you want to. I'm going to just sort of vary how I do this. So this first one, let's use xy. Okay, so we would just have 1x, or just x, okay, and then plus 0y equals -2. And then the second equation would be 0x plus 1y equals 8. So really what this represents really x is -2 because that goes to 0. And then the second equation would be y equals 8. Now I want you to write it that way, all right, to begin with, and then that'll help you understand why this is the solution. So the solution is just -2, 8. that means that these two particular lines would intersect at that particular point, right? Okay, so next one goes like this. Again, let's do x and y. So the first row would be 1x plus 0y equals 9. The second row would be 0x plus 0y equals 1. Okay, well, on this one, think about this equation right here. See, this equation right here really is saying 0 equals 1. Well, that's false. That's impossible. So that's why this would have no solution. So that would be how you'd write the answer is no solution. That just means these two lines are parallel. So from the original system, we'd have two lines that never intersect. That's the geometrical meaning of that. Okay, the next one, just for something different, let's use x1, x2 instead of x and y. So your system would go 1x1 plus 0x2 equals -4. And then what you would have here is you would have 0x1 plus 0x2 is equal to 0. All right, so anytime you have this, if you look at this equation here, that really just says 0 is equal to 0, which is always true. So what we end up getting is we end up getting infinite solutions. All right, now we're just going to, at this stage, we're just going to say infinite solutions. All right, that would end up meaning that geometrically, these two lines overlap at every point because they're the same line. Okay, that would be what happens in that system of equations. All right, so what you want to kind of learn to look for, this is the standard. If you have 1, 0, 0, 1, then this is the answer. If you have a row that says 0, 0, then something that's not 0, that means it's no solution. But you need to understand why so that you'll remember that better. And then the second one, anytime you have or the third one, anytime you have a row of zeros, that means 0 plus 0 equals 0. That's always true. That's why it has infinite solutions. So if you understand how this works into a system, then you will remember this better, okay, instead of just have to blindly memorize it. Okay, so let's go through the next page. Let's go ahead and pause the video and work these out. There should be one of each case. Write down the system and then write down the solution. Okay, so let's check and see if you got this right. So this first one you have, this is saying x plus 0y equals a half, then 0x plus y equals 3/4. So that means really that x equals a half and y equals 3/4. So you write your solution like that. That would be like a point of intersection. Okay, the second one, what you got to do is anytime you see this whole row of zeros, that means you're going to have infinite solutions. All right, so the system goes like this. X plus 0y equals -3, 0x plus 0y equals 0. Now, if you did x1 and y and x2, it's okay. So if you wrote your answer like x1 plus 0x2 equals -3, and 0x1 plus 0x2 equals 0, that's also okay. All right, and this next one, look out for this. 0, 0, then a non-zero number means no solution. So the system on this goes x plus 0y equals 4, 0x plus 0y equals 100. And again, understand the reasoning. The reason for this is this really means 0 equals 100. Okay, that's a lie. Okay, so it's no solution. It's impossible. And on this one, see, this really says 0 equals 0, which is always true. X and Y could be anything, see. That'll kind of help you understand that, hopefully. All right. Okay, so we're kind of got through the basic information on here. Now we're going to do solving a system by Gauss-Jordan elimination. So what I'm going to do is I'm going to do this video in two parts. And the first part will kind of be leading up to this next part here, right? So have fun working this stuff out.